Hello again. Now we're going to solve another example of combination of circuits in series and parallel. And the problem is, this actually is one of the homework problem. Yeah. This one says 4 resistors are connected across an A DC battery, as shown in the figure. And the current and they want to find, we need to find it was the current that goes through this resistor, 9 volts. So as you can see, when the current flows here and it goes to this junction here, part of the current goes to these 2 resistors and part goes to this one. Now that means that these 2 are in series, right? And these 2 are in series. I mean 3 and 9 are in series, 4 and 2 ohms are in series, but these 2 and these 2 are parallel, right? They're seated with each other, one next to it, but they're parallel to the opposed one, to the one on the other side. So just to draw here a circle, how more or less this thing looks, it looks like something like this. We draw this thing. We have, what we're going to do is we're going to turn these 2 resistors into 1, and these 2 down here into another one. And this is actually the circuit that we have here. I put the battery here, it doesn't matter where I put it, here, I put it on the side. But the thing is, we know that when the current goes to this junction, part of it is going to this resistor and part is going to this resistor, right? This resistor is actually these 2. This is resistor equivalent 1, which, because these 2 are in parallel and in series, is going to be what? The sum of those is going to be 2 ohms plus 4 ohms. It's going to be equal to 6 ohms. And this one represent these 2 who are in series, and that resistor equivalent, we can call it 2, we're just going to call 1. It's going to be 3 ohms plus 9 ohms, which is equal to 12 ohms. So now we know this resistor here is 6 ohms, and this one is 12 ohms. Now these 2 here are in parallel. Because they're in parallel, then we have to do the total resistance of the circuit. It's going to be that nasty equation that we've been working for some time, 1/6 plus 1/12 ohms, and the answer is going to be 4 ohms. Do the math, guys. Now that means that this circuit, the equivalent of this circuit with only 1 resistor, will look something like this. It's just 1 resistor and resistor of 4 ohms. Perfect. Now what we need to do now is to calculate the current, the total current of the circuit. Let's move this a little bit. To calculate the total current of the circuit, you remember Ohm's law says the current total is equal to the voltage total divided by the total resistance, right? We already found that the total voltage for this circuit is 8 volts is given. The total resistance happens to be 4 ohms. 8 divided by 4 will give us 2 amperes. So now what we know here, if we go back again to the circuit, is when the current is flowing here, we're having 2 amperes, 2 amperes, 2 amperes. When it reaches the junction, part of that 2 amperes will go here, part of that 2 amperes will go here. How much it will go? Well, that's what we're going to calculate now. Now, something that we know, these 2 resistors here, they are in parallel, isn't it? Right? If they are in parallel, it means that the voltage across these 2 is going to be the same. So if we want to calculate, the first thing we should do is calculate the current that is going through one and the other. So we're going to calculate the current that goes, let's say, from 2 and 4 versus the current that it goes through, let's say, 3 and 9. So the current that goes through 2 and 4 is going to be, well, the total voltage in that case, or the voltage 2 and 4 ohms divided by the resistance of 2 and 4 ohm combined. We just put a comma here so we know it's not 24, but the 2 resistors, and that voltage is 8 volts divided by the equivalent, in this case is 6 ohms. We will get the answer here is going to be 1.3 amperes. And now we go to this one, This one's going to be the voltage that go to 3 and 9 divided by the resistor combined of 3 and 9, which is resistor equivalent to, we called a moment ago. It's actually this one. And it's going to be what? 8 volts, because the voltage is the same, because it's in parallel, divided by 12 ohms. And yes, it's going to be approximately, let's say, 0.7 ampere. And now you can see if you add these two, you will get 2 ampere, which actually is equal to the total. Perfect. Now, going back here again to the circuit, let's read this a little bit. We said that the current, when it goes here, because there's a junction, part is going up and part will go down. We know that the one that went up, we calculated a moment ago for the 6 ohm, which is actually 2 plus 4, it was 1.3 ampere. How much it went down, we calculated a moment ago, it was 0.7 ampere. So how much, so through this resistor, how much current goes? 0.7 ampere. And through this one, because it's in series, 0.7 ampere. That's the answer. The answer for this resistor here. The current is 0.7 ampere. Right? Guys, let me know if you have any questions. You can bother me sending emails and saying, oh, this video is very stupid, it doesn't help me. If you say that, I'm going to be very mad. Okay, take care. Bye. Until the next video. Bye. Hey, I didn't put music at the background. Hey, I'll put it in the next one. Bye-bye.